Welcome to multiplying fractions. So there is a lot of information when it comes to multiplying fractions. I'm going to attempt to hit all of it in this video, so make sure that you use your pause, rewind, and fast forward features as you wish. This is going to be a video that you may want to come back to. I'm going to show you a lot of different methods on how to multiply fractions. You need to pick the one that works best for you. Some methods may be too complicated for you. Some methods may be just right for you. You may understand all of the methods and use them interchangeably depending on which problems you get in class. And you may understand only two of the methods or only one of the methods. And so you need to just figure out what works best for you. But I'm going to present you with all of the options throughout this video. You can definitely follow up with questions for me, but please know that if you have an understanding of some of the methods but not others, that is perfectly okay. I'm going to present you with all of the options in this video. All right, so multiplying fractions at its root is actually pretty simple. So if I have the problem 2 over 5 times 2 over 4, and I need to multiply it, all I have to do is multiply straight across. 2 times 2 is 4, 5 times 4 is 20. And it really does not get much more complicated than that. Now, this answer right here, 4 over 20, is incorrect because it's not simplified, okay? Now, in order to simplify it, we know that we need to find the GCF and, divide by the GCF and make sure it's in the most simplified terms, which would bring us down to 1/5, okay? So, let's go ahead and practice that. Now, along the way, again, I am going to show you tips and tricks to make the problems a little bit easier. And I'm going to start right here. So the first thing I'm going to do is I'm going to solve the problem the first way that I just showed you how. And then I'm going to erase and show you a different way to solve it. Okay? So I'm going to go straight across and I'm going to do 4 times 3, which is 12. And I'm going to do 7 times 4, which is 28. Now really quickly, I'm going to make a factor tree. 4 and 3, 2 and 2, 14 and 2, that's supposed to be a 2, and a 7, and it looks like my GCF is 4, so divide by 4, divide by 4, so the answer is going to be 3 over 7, okay? Now, that problem did not take me very long to solve, but I want to show you a different way to solve it as well, okay? And so what I'm going to do to make it even easier is I'm just going to scoot down a little bit here, and I'm going to rewrite the problem, 4 over 7 times 3 over 4. Now, one thing that you can do before you begin to start solving the problem is you can do something called cross-canceling, okay? And what that means is that you start to simplify or reduce the problem before you actually solve it. And there are several ways that you can do that. So the first thing that you do is you look at an individual fraction, 4 over 7. Can that be simplified any? No. Okay, then you go to the next one. 3 over 4. Can that be simplified any? No, it cannot. Now you actually look diagonal, not side to side. Be very careful. You cannot look side to side. So you can't look at 7 and 4. You have to look diagonal and picture it as if it were a fraction. If I had 3 over 7, okay, if I literally had 3 over 7, because 3's on top, 7's on the bottom, could I simplify that any? No, I couldn't. Now go diagonal the other way. 4 over 4, because there's a 4 on top and a 4 on the bottom. Could I simplify this any? Well, yes, I could. That would simplify down to simply 1 over 1. And so what I do is I cross them out, and I make this a 1, and I make that a 1. Now, here's the cool thing about cross-canceling. If you do this correctly, and you need to keep going back and checking to make sure, because if you cross-cancel one thing, you then might be able to cross-cancel something else. But if you cross-cancel everything carefully, you do not have to simplify at the end. So now that I've cross-canceled, watch this. I multiply straight across. 1 times 3 is 3. 7 times 1 is 7. And I end up with the exact same answer as right up here. Again, this is a method that some people are not comfortable with, and that is okay. Now, what's the difference, Miss Oates? Well, the difference is when I simplify up here, it's typically, yes, I'm simplifying once, but it's much bigger numbers that I'm simplifying. When I simplify here, it's typically much smaller numbers. So let's keep going. Okay, so here again, I'm going to do the first method I did first, and I'm just going to multiply straight across. 5 times 3 is 15. 10 times 8 is 80. Okay, and real quick, I'm going to make my factor trees. So 15 is 5 and 3. 80 is going to be 40 and 2. 2 and 20. 2 and 10, I'm running out of room, and 2 and 5. And it looks like I have a 5 and a 5. So my GCF is going to be 5. Okay, and so divided by that is going to be 3. And 80 divided by 5, let's see, 50, or sorry, that's going to be 10 and 6. I believe it's going to be 16. Okay, so now I want to go back and show you how it would look if I cross-canceled. So I have 5 over 10 times 3 over 8. Okay, I use blue this time. So first I check my fractions. So here I have 5 over 10. Can I simplify that any? Yes, I can. 5 over 10 is 1/2. So I change that to 1, and I change that to half. Okay? Now, 3 over 8. Can I simplify that any? Nope. Now I go diagonal. So 3 over 2. Can I simplify that any? No. 1 over 8. Can I simplify that any? No. Now you're going to realize I'm not going side to side. Side to side does not work. You cannot go side to side. Okay, now I'm going to multiply straight across. Okay, 1 times 3 is 3. 2 times 8 is 16. And that is the same exact answer that I arrived at right up here. Either method works. Okay? All right, let's do another example. So let's multiply straight across. So 3 times 2 is 6. 8 times 9 is 72. Let's do a factor tree real quick. 6 is 2 and 3. 72 is going to be 2 and 36. It's going to be 2 and 18. It's going to be 2 and 9, which is going to be 3 and 3. So it looks like I have a 2 and a 3 that match. So my GCF is going to be 6. So that's going to be 1 over, I think that's 12. Okay. Now let me show you if we cross cancel within the problem. So 3 over 8 times 2 over 9. Okay. Now I look at my 3 over 8. Can that simplify any? No. I look at my 2 over 9. Can that simplify any? No. Now I go diagonal. I look at my 2 over 8. So like I picture it this way, because the 2 is on top, the 8 is on the bottom. Can that simplify any? Yes, it can. That becomes 1 over 4. So I change the 2 to a 1, and I change the 8 to a 4. Okay? Now I go diagonal the other way. I have a 3 on the top and a 9 on the bottom. And I even like to write it out on the side because it helps me visualize it better. Can this simplify any? Yes, it can. That's going to become 1 over 3. So I cross out the 3, that becomes a 1, and I cross out the 9, and that becomes a 3. Now I will say, as you're cross canceling, before I end up multiplying it all back together, I like to do just another quick check. Okay, 1 over 4, that can't go anymore. 1 over 3, that can't go anymore. 1 over 4, 1 over 3. Okay, I'm good to go. Now let me multiply across. 1 times 1 is 1. 4 times 3 is 12. And that matches exactly what we came up with right up here. Okay, so it just depends. Do you want to make your multiplying quick and easy, do your factor trees, find your GCF, and simplify once? Or would you prefer to simplify smaller numbers and then multiply at the end? Okay, so you go ahead and try these two. You use whichever method you want, and then we'll come up with the right answer. All right, go ahead and pause the video if you're not done. If you are done, let's go over it. So I actually did it in both methods so that you could see. In the blue, I did cross canceling, and in the green, I found the GCF. But either way, I ended up with the same answer. I got 1/2 for the first one and 7 over 24 for the second one. Okay? All right. Now, let's take it up just a notch. What happens when I have a whole number times a fraction? Very, very simple process. All we do is when we have 4 times 1/7, we take that whole number, we put a fraction bar under it, and we put a 1 on the bottom, and we multiply as normal. Okay? So we took that 4, we put a fraction bar, we put a 1 under it, now we multiply across. 4 times 1 is 1. 1 times 7 is 7. It's already simplified. That's all she wrote. We're done. All right, so let's practice a couple here. So I have 9 times 1/4. I'm going to rewrite it. 9 over 1 times 1/4. So I'm going to multiply straight across. 9 times 1 is 9. 1 times 4 is 4. And we are left with 9 over 4. Now, just to practice, let's also make that a mixed number. How many times does 4 go into 9? 2 times. Okay, 2 times 4 is 8. What's the difference between 8 and 9? 1, and keep the same bottom. Okay, right there. And it's already simplified. Now let's look at this one here. So 3 times 5 over 18. So again, just take that 3, put it over a 1, times 5 over 18. Okay, multiply yourself straight across. 3 times 5 is 15. 1 times 18 is 18. Now this is not simplified. Make yourself a factor tree. Find your GCF. Looks like your GCF is 3. So it's going to be 5/6 is your answer. Now let me show you the way to do it with cross-canceling. So again, you take that 3 and you put it over 1 times 5/18. Okay, I'm going to take out my blue and cross-cancel now. 3/1 is as simple as it gets. 5/18 is as simple as it gets. Now I'm going to go diagonal. 5/1 is as simple as it gets. I'm going to go diagonal this way now. 3/18, I can simplify that to 1/5. That becomes a 1. That becomes a 5. Did I do that right? I did not. I'm sorry, not 1/5. 1/6. I'm sorry, because 3 goes into 18 6 times. Okay? And now, let's multiply straight across. 1 times 5 is 5. 1 times 6 is 6. And I got 5/6 without making factor trees, and that's the same answer as before. So again, I'm just showing you different methods so that you know that you have different options. Okay, so you just do these two as practice. Remember to put it over 1. Use whichever method that you want. All right, so for the first one, I got 2/5, and I used the cross-canceling method. For the second one, I got 5/3. I also put it in a mixed number for you, 1 and 2/3, and I also used the cross-canceling method. Either method will work. I prefer the cross-canceling method, but again, either method will work. Okay. One more situation to throw at you, okay? So we've done so far fraction times fraction, and we've done whole number times fraction. Now, what about mixed number times mixed number? Again, very simple, quick fix. All you need to do is take this mixed number, change it into an improper fraction, multiply as normal. So 4 times 1 is 4. Plus 3 is 7, and here we have 7/4. Here we have this guy. 5 times 4 is 20, plus 2 is 22/5. Okay, I'm going to use the cross-canceling method here. So I have 7/4 is as simple as it goes. 22/5 is as simple as it goes. I'm going to go diagonal. 7/5 is as simple as it goes. Now I'm going to go diagonal this way. 22/4. I think I could divide by 2. So I'm going to make that 11, and I'm going to make this 2. And now I'm going to multiply right across. 7 times 11 is 77, and 2 times 5 is 10. 77/10 would be my final answer. And then I can also make this a mixed number. How many times does 10 go into 77? It goes in 7 times. 7 times 10 is 70. What's the difference between 77 and 70? 7, and you keep your same bottom. Okay? So either way will work. All right, let's do some practice with those here. So let's change this guy into an improper fraction. So 2 times 6 is 12. 12 plus 1 is 13. So we have 13/2 times And then let's change this guy here. 3 times 2 is 6, plus 1 is 7. 7 over 3. Okay, we'll do it the normal way first. Let's multiply straight across. So 13 times 7, so I'm going to have to work that out up here. So that's going to be 21. So that's going to be 91. And then here we have 2 times 3 is going to be 6. And you know what? I'm looking at this. 3 over 2, 7 over 3, 7 over 2, 13 over 3. You cannot cross cancel anywhere in there, which means this is as simplified as it goes. And to prove it to you, here's a factor tree of 6. And 91, it's not prime, but here's the factor tree of 91. So they don't have anything in common. But let's go ahead and try to make it a mixed number. So 6 goes into 91. We're going to have to do a division problem for this one. So it goes in once, 31, 5, 31. So it's 15 and 1/6. There we go. All right, next one. Okay, so we have 1 and 5/6. So 6 times 1 is 6, plus 5 is 11 over 6, times 4.5. 2 times 4 is 8, plus 1 is 9 over 2. Okay, now let's go ahead and multiply straight across. 11 times 9, 99. 10 times 2, or 5 times 2, which is 10. This is another guy that cannot simplify. Very interesting. So no cross-canceling action could happen here either. All right, let's make him a mixed number. How many times does 10 go into 99 evenly? 9 times. What's the difference between 90 and 99? 9, and you keep your same bottom. There you go. No cross-canceling action here. All right, so you have 6 to try on your own, and then that's the end of the lesson. I will post the answers, and then we'll go from there. All right, so if you are not done, you can hit pause and keep going, but these are the answers. So in a lot of these, you had to change from mixed numbers back to improper fractions. You had to take whole numbers and put them over 1, so this was really a great practice. Make sure that you check your answers. Make sure that you ask me any questions that you have in class. Multiplying fractions are going to become very important, and they are the basis for dividing fractions as well. But you survived and you made it to the end of the lesson. And make sure that you let me know if you need any help. Congratulations.